Hey everyone, welcome to Code Harmony. Today we are going to cover LeetCode problem ID 1910, remove all occurrences of a substring. This question belongs to the string matching category and recently has been asked in good companies like Google, Microsoft, Amazon, Adobe. Let's have a look on the problem statement. We are given two strings, s and part. We have to perform the following operation on s until all the occurrences of the substring part are removed. Okay. This is the input given to us. We have to perform some kind of operation until all the occurrences of part is removed from S. So the operation is for sure removing something from S. Find the leftmost occurrence of substring part. We are given S. S is, you can say, our text. And part is, you can say, our pattern. And this pattern we have to find the first occurrence. Let's say first occurrence is at this. Just remove the first occurrence and then whatever is the new string, just keep on applying that operation until there is no substring which is equal to part. Return S after removing all the occurrences of part. A substring is a continuous sequence. Okay. So now the problem statement is clear to us. Let me explain it to you again with the help of an example. First of all, what is given to us? We are given two strings S and part. And they are saying that we have to check a part as a substring in S and then we have to remove it. That is our operation. So given is two strings. What is the operation? Find the leftmost occurrence of part. You can say substring pattern in string S and remove it from S. Two strings are given to us and our operation is for this pattern, for this part, we have to see whether the part is a substring of S or not. In this case, I can directly see that ABC is present at this and this is the first index, first occurrence. Just remove it from the string and the remaining string is D, A, B, A and so on. And keep on removing it until you are no longer having any substring which is equal to part. After removing all the occurrences, we have to just return string from our function. This is our problem statement. Now let's try to apply whatever is saying to us, whatever operation we have to perform on the example set. This is the example we are having, and if we keep on applying operation one time, this is the operation for the first time. ABC substring is present at this moment and we have to remove it. After removal, we are left with this string. And again we have to apply the operation second time. Here in this case, the ABC is present at this position. I have removed it and then this substring is coming. Then again we have to get ready with the third operation. In third operation we have to remove this one. And in the end we are left with this string DAB. And in this DAB I don't see any occurrence of ABC pattern. So there is no further allowed operation. So we have to return this string from our function. So this is pretty simple for us. If let's say we are having some kind of utility function that is going to give us the first occurrence in the string. First occurrence in string for part. Let's assume that we have a utility function and that utility function is this. If we have that utility function, then what is going to be the algorithm? While true, as long as we are getting part as a substring in S. Find the index of the first occurrence and then we have to remove that occurrence. Let's say in this case A, B, C, A, B, and let's say the pattern is CA. CA is present at this position and this index is 2. So this utility function is going to give us 2 and then we have to remove this occurrence. Now we have to combine this string with this string and remove this pattern. So how we can do that? String is definitely going to start from index 0 and this is 2 minus 1. If I take 2, we already know that the substring is exclusive and inclusive. Okay. So what I'm doing is, as far as I'm getting the pattern, find the first index and then remove that. Removing logic is in this instruction. S will be updated to the left portion plus right portion. The middle portion where the substring is present, that has been removed. And if by any chance I am getting the index as -1, in this case I can get to know that okay, the pattern is not present. If the pattern is not present, just break it. If we have break the while loop, then return whatever s is we are having. So this is our naive algorithm for that, finding the first occurrence. So finding the first occurrence is our priority in this problem statement, and this is expected from us. What is this finding first occurrence? See, in the string problems, the main category is string matching, that you are given a text and you are also given a pattern, and in this text you have to tell me whether the pattern is present or not. If it is present, then at what index it is present. So in this case, the same thing is being asked. In the text, search for the pattern. Whenever the first occurrence of the pattern is coming, just return from the function. And this operation is being applied as long as the pattern is found in the string. Okay, so the main approach, main logic is finding first occurrence in S of part. First occurrence of part in string. So that is our subproblem. Finding first occurrence. And now how you are going to do that? S string is given, part is also given. Finding the first occurrence of part in string. That is something I have to do, which is called string matching. And for the string matching, we are having two famous algorithms, which is naive algorithm. Naive algorithm for string matching, where I am going to match my pattern starting every index in S. And second one is KMP. Let's say you are searching a word in the Word document, you are able to get the result very fast. Why? Because the string matching KMP algorithm is going to give us the time complexity of n plus m, or in short, we can say that it is going us linear time, and this naive algorithm is going to give us quadratic time. Now the task is that you have to cover this problem. Knuth Morris Pratt algorithm, KMP. This is a detailed video of around half an hour. In this video I have covered KMP algorithm in a highly detailed manner, covering all the aspects, so you won't find it difficult to understand if you watch this video first. I'm going to attach this video in the description below. But if you are somewhat aware of these algorithms, naive algorithm is going to give us the time complexity of order of n into m, where let's say n is the length of S, m is the length of part in this case, but it's quadratic. And KMP is going to give us the time of n plus m, which is linear. Okay, so now we are going to apply finding the first occurrence in this case, and whenever getting the first occurrence, we are just returning the index. In short, we just have to do the implementation of string is given, part is given, just find the implementation of first occurrence in string. Now this is where our problem has reduced to. Now I will directly show you the code where I have done this using KMP algorithm, KMP utility classes. I also submitted it using inbuilt function. Why inbuilt function are important? Because they are already implemented with efficient algorithms. But in the interview, we are expected to know the logic behind that algorithm. But KMP, you can say that it is the most important algorithm of string section in DSA. Now let's have a look on the approach. Now we are going to have a look on the code, but before that let me tell you that this video is very important and a prerequisite to understand this code, master the KMP algorithm. I am going to attach the video link in the description below. Now let's have the code, have a look at the code. The main function is remove occurrences. While as long as we are getting the occurrence, find the first occurrence using KMP, and if you are not able to find the occurrence, it means we are done. Otherwise, find the first occurrence and remove the first occurrence. I hope you are able to understand this statement. Substring, the left portion, the right portion of the pattern. Now this is the core function, kmp.kmp. For the KMP, I have a class prepared already. First of KMP is having two major steps. First one is preparing the LPS array, longest prefix suffix for any pattern. Let's say the pattern is something like this, ABC, ABC, and for this pattern we have to prepare the longest prefix which is equal to the suffix. Firstly, the string is A, and for the first character we already have 0. AB. For the substring AB, what is the LPS value? LPS value is 0. And for ABC, LPS value is 0. And then for ABCA, for this substring, there is a prefix A, which is also a suffix. So that is going to be 1. And for this string ABCAB, that is 2. So further 1, 2 and 3. This is the LPS array. We have to prepare the LPS array first, and then we have to use the LPS array to find out the pattern. And here in this case, if you have a look on the problem line number 64, j is equal to LPS of I minus 1. This is the step where we are avoiding the repetition as compared to the naive algorithm. And why KMP is going to give us the order of n time? Because after preparing the LPS array preparation is going to take order of pattern dot length time, and then iterating over the text dot length. So searching is going to take order of n time. Preparing LPS array is going to take order of m time. Overall it is n plus m. You can get a very detailed understanding if you just watch the video on KMP. And now here I am using the KMP as a utility function. So this is the core logic. And why I'm doing so? Because there might be a possibility that after getting one occurrence from the left portion and from the right portion, let's say from the left plus right portion, this portion might form another instance. So we are processing one instance at a time. Now let's run our sample test cases. I'm submitting the problem. It got submitted successfully. I hope you understood the approach. Thank you guys. Bye bye. If you get any doubt, you can comment down below. I will be happy to help. Bye bye.